Hey everyone, and welcome to our new unit. This is the unit where we're talking about oceans and weather. So today we're starting with ocean water. So as you know, there are two different types of water on Earth. We've got fresh water and then we've got salt water. And we know that fresh water makes up lakes and rivers and ponds, and salt water is what makes up our ocean. And if you've ever been to the ocean, you've probably tasted how salty the water is. And so now, when we talk about the saltiness of a body of water, we use the term salinity right here. So, in oceans, salt makes up about 3.5% of water. Therefore, the average salinity of the ocean is 3.5%. Now, this doesn't seem like much when you think about it in terms of percentage. It's only 3.5, but it's definitely a lot of salt in the ocean, and you can feel that when you get in the ocean and the salt water hits your eyes and your eyes start to burn, or when you get it in your mouth and it just tastes horrible. You can really tell how much 3.5% really is, okay? So now, because rivers and streams that are freshwater, they, eventually run off and land in the ocean. You learned about this in seventh grade. The areas where that runoff meets the ocean, those areas are going to have less salt water percentage in that area. That's because the fresh water is diluting the amount of salt in that area, okay? But on the flip side of that, salinity is higher in parts of the world where the water molecules, H2O, are quickly evaporating, okay? And so that means that when they are in areas that are more higher temperature. So think about the equator, it's hot there. Water is being evaporated more quickly in those areas, and that leaves a larger concentration of salt in these areas. Okay. Now, salt is very dense. That being said, salt water has a higher density than fresh water. This is because the molecules that make up salt, NaCl, have a higher density than the molecules that make up water, H2O, H and O, oxygen and hydrogen. So salt water has a higher density than fresh water. This, and you remember from sixth grade that dense things sink, okay? So that means that the salt is going to kind of sink in the water and things can float on top. So if you've ever been to the Dead Sea, or if you've heard of the Dead Sea, this is a place where it is so salty that people can float in just about 1 foot of water. Now, I visited there a few years ago and I walked in from the beach about calf deep, so below my knees, in the water. And I just sat right back, leaned right back, and sure enough, I floated in just a little bit of water. It was really, really cool, but super salty in this area. So, when we continue talking about salinity, remember that the ocean water is a solution, okay? And if you remember from sixth grade chemistry, a solution is a mixture of things. So, in this case, we have a mixture of elements that make up the ocean, with sodium and chlorine acting as the main solute. Okay, so for every 100 grams of water, there are 3.5 grams of salt. Okay, so that's how we get that 3.5%. Okay, so now all 92 naturally occurring elements can be found here in the ocean water or on the ocean floor. And that's pretty cool. Just think about how amazing it is that all of the elements that we've discovered can be found somewhere in the ocean. All right, and now the last thing that I wanted to talk to you guys about in regard to ocean water are these charts and tables. So I want you to take just a few minutes and look at each one, and if you need to pause the video, that's fine. But make sure that you can really understand and process the different amounts of salts in the water, the different amount, let me move my picture here, the different amount of different elements that you can find in the ocean water and the percentages of each. So I just want you to take a second and really analyze these tables, okay? All right. So now we're going to discuss currents. So here we have a map that shows the specific uh, currents and how they flow throughout our Earth. Now you can see that the cold currents here, the ones in blue, they kind of flow toward the equator. Y'all see that? From here, they flow toward the equator. From the top, from the northern hemisphere, they go down toward the equator. And then the warm currents are flowing away from the equator. So they're going to go south in the southern hemisphere. They're going to go north in the northern hemisphere. And that makes sense, right? Warm things are at the equator where the sun hits our earth most directly, right? And then cold things are at the poles. Now, because they flow, the cold water is going to head toward the equator where it'll warm up and then it'll head back to the poles. And this cycle keeps going. Think of this as a big giant conveyor belt with their repeated motions. And now we're just going to talk about the 4 factors that influence currents, okay? So first we have the sun. The sun is going to heat surface currents of the ocean, and that will cause convection. Now you might remember from previous science classes that convection is the process of circulating motions of fluid, okay? So a fluid is a gas or a liquid, and they're heated and cooled and heated and cooled, okay? So gases and liquids are heated as they rise and then they cool as they fall. And convection happens in the ocean, and it happens in your convection ovens at home. It will happen right on your stovetop as you're heating water, and you'll see the convection at work while it boils. And we'll talk about convection more in a minute, okay? Next, we've got wind. Winds below the surface currents um, will flow in different directions, okay? This is where we get easterlies and westerlies, directions of wind. And then we've got the Coriolis effect. This is caused by the Earth's rotation. So in the northern hemisphere, the currents are going to turn clockwise, while in the southern hemisphere, they're going to turn counterclockwise. And finally, we've got continents. Continents are going to act like a barrier to the currents, okay? The currents can splash up against the Earth's surface and the continent surface, okay? So now, surface currents make up 10% of ocean's water. Only 10% on the surface of our oceans. Now, when we talk about surface currents, we're talking about 400 meters deep. 400 meters deep. Now, I know that 400 meters deep sounds like a lot, but when you're talking about the depth of the ocean, 400 meters is just skimming the surface. Surface current. It's a bad pun, I know. Um, so, when we can see here illustrations that are showing convection right here, okay? And so you can see it on a larger scale. Remember that water is cooler the deeper you go. As wind moves away the water on the surface, the cooler water from underneath will move into its place and become warm, right? And then it'll get moved again by the wind, and the water from underneath will rise again, so on and so forth. This process is known as an upwelling. Upwellings cause this convection to take place. Okay, now we've got deep water currents. So these are currents that make up 90% of ocean's water. Remember, surface currents were 10%, deep currents are 90% of ocean's water. So the temperature and the salinity of these waters cause them to be more dense than surface currents. Now remember, dense things sink. So remember, deep water currents are made of cold water that is more dense. There's more salt down there, okay? So the last thing that I wanted to tell you about was the term gyres. These are circulating, moving loops of water found throughout the world. Now, you can see this demonstrated right here in this picture, okay? So on a large scale, there are 5 main gyres that are always circulating throughout our world. And you'll notice that toward our equator, the water is warmer and the water moves away and cold water rushes in its place. And this is an ongoing cycle. All right, you guys, that's it for this lesson. So please reach out if you have any questions. Thanks, guys. Bye-bye.